Welcome to the deep dive. Today we're looking at some really stunning material from the European Southern Observatory, ESO.
Yes, specifically focusing on the extremely large telescope, the ELT, down in Chile.
Right, and our mission really is to unpack the significance of this thing, this huge telescope, and also this one incredible photo taken during its construction.
Ah, you mean the one with the full moon?
Yeah.
It's quite a spectacle. It
Yeah.
shows the telescope structure perfectly framed.
Exactly that one. It just nails the ambition, doesn't it? Human engineering meeting something cosmic.
It really does. Snapped by Juan Beltrán from ESO, I believe, shows the ELT's framework against the moon on Cerro Armazones.
And there's this weird sort of halo around the construction site in the picture. What's that about? Is it dust?
Good eye. It's likely light scattering off the thin, high-altitude desert air, maybe interacting with construction lights.
Okay.
It really highlights what an extreme environment they're building this in. But that's why it's there, those clear, stable skies.
Makes sense. And this ELT, it's set to be the world's largest optical and infrared telescope, right? A 39-meter mirror.
That's the one. Huge. And it's segmented, made of many smaller hexagonal pieces working together.
Why segments, though? Why not one giant mirror?
Well, a single mirror that size is practically impossible to make, transport, and maintain. Segmentation lets you build much bigger light buckets, essentially.
Buckets, I like that. And optical and infrared.
Crucial. Different things in space shine brightest at different wavelengths. Optical is what we see. Infrared pierces through dust, shows cooler objects.
Yeah.
You need both for a complete picture.
Got it. So this giant eye, this light bucket,
Oh.
what's it looking for? What are the big science goals?
Oh, the potential is amazing. They want to look back at the earliest galaxies just starting to form after the Big Bang
Wow, okay.
and study exoplanet atmospheres, actually analyze the air on planets orbiting other stars, maybe looking for signs of life like oxygen or methane.
You're kidding. Analyzing alien air.
That's the goal. Plus, investigating dark matter and dark energy, the sort of invisible stuff that seems to dominate the universe.
Huh.
So, yeah, big questions.
Absolutely huge questions. We also saw some construction pics, giant cranes, these sort of shimmering panels being installed.
Right, that's the cladding. Basically, insulating panels. They're vital to protect the super-sensitive telescope and its instruments from the desert extremes, temperature swings, sunlight.
So like a protective skin.
Exactly.
Mm.
And you can also see one of the massive sliding doors for the dome going up in some shots. Gives you a peek at the immense structure inside. Symbolizes the company heading up the construction work there.
And it's not just about being big, is it? I read about adaptive optics. Sounds fancy.
It is fancy
Yeah.
and incredibly clever. Think of it like prescription glasses for the telescope.
Okay.
Our atmosphere blurs starlight, makes things twinkle, right? Adaptive optics uses deformable mirrors and lasers to counteract that atmospheric turbulence in real time.
So it untwinkles the stars.
Basically. The results should be images up to 15 times sharper than the Hubble Space Telescope can manage from space.
15 times sharper than Hubble. That just changes everything, doesn't it?
It's a complete game changer for ground-based astronomy, yeah. A whole new level of detail.
And all this is happening in the Atacama Desert. We touched on why the conditions.
Yep. High altitude, super dry air, almost no light pollution. It's one of the best places on Earth to look at the night sky.
ESO's Parallel Observatory is nearby too, right? With the VLT.
That's right. It's a major hub for astronomy. And that amazing moon photo we talked about, taken by someone from the Parallel team. It all connects.
So summing up, we've got this absolutely colossal telescope packed with cutting-edge tech like adaptive optics being built in maybe the best spot on Earth for it, aiming to tackle the biggest cosmic mysteries.
That's the gist of it. And that image of it against the moon is just such a perfect symbol of the whole endeavor.
It really is. So maybe the final thought for you, listening.
Yeah, think about this. A telescope that can see so much further, so much clearer than anything before. What completely unexpected things might it reveal out there?
What secrets could it unlock?
Exactly. And how might finding those secrets fundamentally change how we see ourselves and our little spot in the universe? Something to ponder.